When we talk about automotive surface quality, gloss is only the beginning. A painted surface can meet gloss specifications and still look unacceptable to the human eye. That's because surface appearance is controlled by how light is reflected, scattered, and distorted, not just how much light is reflected. In this section, let's clearly understand the core surface properties measured in automotive coatings and why each one matters. Specular gloss is the most basic and most widely known measurement. It measures the amount of light reflected in a mirror-like direction at specific angles, typically 20 degrees, 60 degrees, and 85 degrees. At 20 degrees, the measurement is highly sensitive to very smooth, high-gloss surfaces, which is why this angle is critical for automotive clearcoats. At 60 degrees, gloss measurement represents a balanced, universal reference and is commonly used for general quality control. At 85 degrees, the measurement becomes sensitive to low gloss and matte finishes, where small visual changes would otherwise be missed. Specular gloss tells us how smooth a surface is at a micro level, but it does not describe how the reflected image looks. That is why gloss is considered a quantity measurement, not a visual quality measurement. Next comes reflectance haze. Reflectance haze quantifies light that is scattered very close to the specular reflection direction. In simple terms, gloss measures how much light is reflected, while haze measures how clean that reflection is. A surface can show very high gloss but still appear milky or cloudy due to high haze. High reflectance haze reduces contrast and clarity, making reflections look washed out. This is especially critical in high-gloss automotive clearcoats, where even small increases in haze can destroy the premium appearance. Haze is commonly influenced by microsurface structures, flow behavior, contamination, and curing conditions. That's why haze control is essential for dark colors and high-end finishes. Now, let's talk about distinctness of image, or DOI. DOI describes how clearly a reflected image appears on the painted surface. It is typically reported on a scale from 0 to 100, where higher values indicate a sharper, clearer image. Lower DOI values indicate surface distortion, commonly associated with orange peel or fluorilated texture. Two panels can have identical gloss values, but completely different DOI values. The panel with higher DOI will always look smoother and more premium to the human eye. DOI is extremely sensitive to application parameters such as atomization, leveling, flash time, and rheology balance. That is why DOI is one of the most important appearance parameters in automotive OEM specifications. Reflected image quality, or RIQ, takes DOI measurement one step further. RIQ is a higher resolution evaluation of reflected image clarity that more closely mimics how the human eye perceives surface quality. While DOI gives a general clarity value, RIQ detects subtle surface textures such as long-wave waviness, brush marks, roller marks, and fine flow lines. This makes RIQ especially useful for evaluating premium clearcoats and large exterior panels. OEMs often prefer RIQ when distinguishing between surfaces that are technically acceptable but visually different. In other words, RIQ separates good surfaces from truly excellent ones. RSPEC, also known as peak reflectance, measures the maximum reflected light intensity within a very narrow angular range. You can think of RSPEC as a zoomed-in gloss measurement focused only on the sharpest reflection peak. RSPEC is highly sensitive to very fine surface texture changes that standard gloss measurements may miss. It is often used to compare panels that already meet gloss requirements but differ slightly in visual appearance. In production environments, RSPEC is commonly used as a trend monitoring tool to detect early surface quality drift before visible defects appear. Finally, we come to Goniophotometric curves. This is one of the most powerful tools in surface appearance analysis. Instead of measuring reflection at fixed angles, Goniophotometric measurement analyzes reflected light across a wide range of angles. The result is a reflection intensity versus angle curve, which acts as a complete optical fingerprint of the surface. Two surfaces with the same gloss and DOI can still produce very different goniophotometric curves. These differences reveal variations in surface roughness, texture wavelength, and flow behavior that the human eye subconsciously detects. OEMs and coding developers use these curves to correlate instrumental data with visual perception, debug complex appearance issues, and understand why lab panels pass while vehicle bodies fail. To summarize, specular gloss is the entry point to surface evaluation, but it never tells the full story. Haze defines clarity, DLI defines sharpness, RIQ defines perceived quality, RSPEC reveals microtexture differences, and Goniophotometric curves expose the complete surface behavior. In automotive coatings, surface appearance is not a single number. It is a combination of optical properties working together to create a premium visual experience. Understanding these measurements is what transforms paint application into true appearance engineering.